Yeah, so I'm Glyn Edwards. Just a little bit about myself. I'm actually independent. I work for myself. So that I'm associated with Black and Veatch. They're actually one of the people I subcontract to. I've been involved in sort of all aspects of biomass for years, but perhaps over the last 5 years in the UK, much of my previous experience has been overseas. But in the UK, last 5 years, I've been doing quite a lot of feasibility studies, specifying systems, sizing systems, going right through to tendering with people. And then on the fuel side, I've run a wood fuel business, run a pelleting plant. But as time's gone on, I've been working for other people. I've either been working to help people on the fuel supply side develop their businesses, fuel quality, for instance, specifications, and on the other side of that, I do buying and negotiating for people. So I buy on people's behalf or act as an agent for them. So I'm quite heavily involved in sort of the biomass fuel side, and as time goes on, that's where I'm gravitating towards. Okay, so fuel. It's already been said that fuel has to be considered really right from the start of the project. It has a major impact on project design and economics. Okay, and what I often see is working, particularly things like in the public sector, there's a total disconnect between the fuel and the engineering and the civil engineering side. So people say, yeah, we want a biomass boiler, and it goes out the tender, goes down the subcontracting chain, and people start putting the boiler in without even thinking about the fuel, and you get all sorts of disconnects. You get disconnects in terms of economics. People end up being restricted to a very small variety or small spectrum of fuels, and that may not be the best in terms of price. They get restricted in terms of how that fuel is delivered, and again, the large part of the fuel price is in the logistics of the fuel in terms of transport and processing. And so it really needs to be a successful project. It's got to be tracked like a system, and fuel has got to be right there from the start, not left as an afterthought, as unfortunately it has been in a number of projects, particularly, as I said, that are going in and where the engineering has been treated almost separately from the long-term operation of that boiler. Okay. So why do you need to engage with fuel suppliers? And really, this is reiterating what's already been said to a degree. You need to know to inform the boiler specification and any consent requirements. Consent in terms of not only planning but emissions. So you need to know what types of biomass fuel are available, the grades of fuel, and for wood chip there's set standards, and boilers come with set standards of what they will burn. The two have to match. Okay, so you've got two variables there. You're looking for the optimum between the two in terms of economics and performance of the system. So you need to know the moisture content and the likely variance. It doesn't just come, you say I'm buying 30% moisture content. It is not 30%. It may be between 25 and 30%. You've got to make sure the variance of that fuel you're getting from your supplier actually fits with the variance that the boiler, not only the boiler can burn, but what it's commissioned on. You don't want people running back and having to reset the boiler every time there's a change. Okay, so you need to know what game you're playing. Source of material, that may be important for sustainability issues. Details of quality assurance procedures, level of potential contaminants, metals, stones, etc. With many of these things, you do get some stones. Okay, for instance, with wood fuels, you may get the odd stone. With straw, you almost certainly get stones. That may not matter. Okay, if they're small, and but also it depends on the boiler. How sensitive is the boiler to that? And if you're getting a dirtier fuel, you have to have a more robust boiler. So the specifications of both have to be, they're closely linked. So you need to inform fuel storage design and reception requirements. There are different ways of of doing this in terms of getting your fuel. Now, some of you, you know, if you're considering larger systems, you may even be going right back and saying, well, I actually want to have my own processing because I can get economics of scale and it pays me to do so. And there's a couple of glass houses up in Lincolnshire that do that. So they have their own wood fuel storage yard. But this is really coming from the point of view, if I'm buying it in, okay, what are the delivery vehicles being used? Volume of the fuel deliveries that possible, and the minimum volume of the fuel star required to discharge a full load. And what I see sometimes there, I mean, there's been some poor practice in the past from people who really don't understand how things like wood chip behave in terms of their flow or lack of it, and how it sort of sits in the hopper, and if you've got an underground storage hopper, you come along, or above ground with a ramp or something, people think, oh, 50 cubic metre load, 50 cubic metre hopper. No, it doesn't work like that, because it sits there, natural residence angle of chip, something about 45 degrees. And so very, very simple issues like that. Okay. Physical access required for the vehicles. I've seen projects, unfortunately, where there's been insufficient room for manoeuvre, or you've restricted yourself to a smaller, a small range of vehicles, and then shot yourself in the foot for later on when you want to change that for get a better price. And height clearances. The key point is you really need to avoid 20 years of awkward and very costly fuel delivery. Time is money. Now, this really reiterates what was said earlier. It's a system, and you need to think about it as a system early on. It will inform the design, and that's a two-way process. You also need to inform the economic appraisal. You need to know what the price of the materials, minimum delivery quantities to achieve competitive pricing, and the variance in fuel costs between an optimally sized fuel store and a fuel store requiring a great number of deliveries. Now, all of these play offs, to you, because you operate businesses, you know about logistics, you know about that, probably pretty common sense, but you still need to do it from the start and think it through, and not leave it as an afterthought, because there may be a few stings in the tail. And I've seen people that even quite experienced, wow, oh dear, we can't get a walk-in floor trailer in here because we didn't think about the turning radius of these things. And to negotiate and finalise contracts and documentation. If you want complex contractual arrangements, such as forward pricing, start negotiations early. These things can take quite a long time. And you may need other documentation, but also to give adequate notice to the fuel supplier. These are bulk commodities, and sometimes they have significant lead times. For instance, if you're using a drier wood chip, that wood needs to be seasoned, and you can't just click your fingers and expect to have a guy with 1,000 tons of seasoned wood there. It may take him a summer to achieve a 30% moisture. Now, for the size of projects we're talking here, you probably wouldn't be burning 30% moisture content chip, but the same principle, the guys, or fuel supplier's got to go out there and source it, and he's not going to sit on large inventories if he hasn't got a market for it. So engage early. All fairly straightforward stuff, and it's a sort of gated process. I produced this. Really, this is much more applicable to situations where there's a chance where the engineering and the fuel supply get separated. But basically, you're doing a feasibility study, you're doing a market survey. What's out there? How much is it going to cost? Who's going to deliver it? What are my options? And that will then inform, through the feasibility, at some point here, you'll come out with a preliminary boiler fuel solution, okay? With your specification, you'll then go back and you'll revisit that. But all the time, you're narrowing down your choices. You're giving something away, okay? So you may go back and say that's too expensive, and you value engineer it to end up with a cheaper system, but you may have restricted what fuels you can put through that system in terms of moisture content, for instance, or particle size. And you really need to know what you're giving away so that you're making informed decisions. And what I see quite often is that the client, who's going to be operating this for 20 years, is having freedom, flexibility of that system given up by people who are not incentivized to look at it. They're actually incentivized to put in a cheaper system, okay, because they're on a fixed price contract to put it in, for instance, as in many public works. So know what you're giving up and think it through. That's the basic message. So let's talk a little bit. I mean, we can't really cover. It's a pretty broad subject, fuels, and we could sit here and go through each, all of the fuel characteristics of different type of fuels. But I think it's more important that we just go through at a broad brush. We haven't got time to do all of that. So I'm just going to talk about really a couple of fuels, and which are probably most relevant, which is straw and wood fuel. In terms of what's out there, now I always put myself into the position of the person who's actually investing and saying, if that was my money, would I do it? What would I do? Okay, and if I was sitting in your position, I was considering this, think, well, hang on a minute, where's my fuel going to come from? We know that there's, fossil fuel oil price has gone up. We know that there's limited resource. So am I going to go and spend X 100,000, even £1 million to put in a system and then find myself in the same boat because of difficulties with supply and high prices in the future? There is lots of information around about availability of straw and wood fuel, but it needs to be interpreted with care. And to a great degree, it is, depending on the fuel, there's a local element because of the costs of transporting these things. And we'll come into that in a minute. Okay, so there's many sources that indicate total production potential, but they don't take into account the logistical and commercial reality. There's a dynamic and expanding biomass fuel market, but there's national and regional competition from other sectors. And again, that's sometimes underestimated. People think, oh, wood, so it all can go in biomass. There's established industries out there that use wood in various grades, and I'll talk about some of those. And unfortunately, there's no single reliable and up-to-date data source. So I'm going to talk a little bit about straw first, just to go through so you can see what sort of information is out there. This is the easy one. Wood fuel is much more difficult. Okay, so there's a very good report study out there, which I've quoted, which gives 2007 straw production estimates across the UK. So you end up with total cereal straw about 9.3 million tonnes and oilseed rape straw of about 2.5 million tonnes. That's quite a lot of straw. But what it doesn't actually, that's the headline figure, picks up plenty of it, but it's regional because of the cost of transporting this across, and because there's demand. Okay, so we've got demand in the west for bedding, and we've got predominantly production in the east of the country. And what this map does, it says county by county, it tries to estimate what the surplus or what the net balance is. And I've picked a few. It's got all the colour coding there, but I've picked a few out. So Lincolnshire, somewhere between 657,000 tonnes of surplus straw. And you can run through all of these. When you get down to along the south coast where we are here, there's less. Okay, 250 to 300,000 tonnes. But there's also a price differential, obviously, as you go across there, which reflects transport costs as well. So there's quite a lot of straw. What it doesn't actually show here is that you'd expect Cambridgeshire to have a lot more, but there's the Ely power station there, which burns about 400,000 tonnes. Okay, now there are plans for 2 equivalent stations to go into Lincolnshire. Now whether they're going to go ahead or not, I don't know, but you have to be aware of that. If you're going to put your significant size system in and then suddenly find that there's big local demand, then it is going to impact. Okay, and this is the big problem with wood chip, because you can do a similar sort of production maps how much woodland there is if we're talking about virgin forest fuels. But what it doesn't say is what all the local demands are, and they can be quite significant. For instance, up here there's Kronospan, which board manufacturer, massive board manufacturer, and they buy in low-grade timber, which is directly in competition with the biomass roundwood market. So they buy it in, lorry loads of stuff go up there. They buy it in quite cheaply, so 22 quid a tonne, which is fine, but you're in direct competition with there. But as you move away from there, obviously the haulage costs mean that you can compete quite well. Because of the costs of hauling it up there, and the economics become unsustainable. The other thing is that there's a lot of biomass plant, which, well, there's relatively small amounts of biomass plant that have gone in so far, smaller capacity. But there are quite a few plans for plant to go in because of the RHI. There's a lot of people sitting there waiting for that document to be published. So what you don't know is another source of competition which is really emerging is for logs as well, because people are putting in wood fuel stoves. And you say, well, logs, that won't be a very big market. But there's one supplier that I know quite well down here is now doing 14,000 tonnes of just firewood logs, and there are other people, so there's consolidation in that market, but it's also, there's still a lot of other smaller suppliers. So we've got a dynamic situation. You know what the total production might be, but that's steady state, but we really don't know what the demand is and will be. Okay, so probably the best figures to go on are these. If we start with forest wood fuel, this is a terawatt. This is steady state, okay, in terms of what's the production potential estimates. That's terawatt hours of primary energy, and for forest wood fuel they're saying about 13, which equates to about 4 million tonnes at 30% wood chip, which isn't as much as so this is what will be available for biomass. But that's at steady state. On the plus side of this equation is that this is steady state, but what we have is about 50% of English woodlands have been undermanaged for at least the last 60 years. And what you have is a very large inventory of standing wood in those woodlands. Now there are incentives to manage those, and as the price increases, people are going to start managing those, and that wood's going to come out. So there's a lot of standing wood there which isn't included here. And I recently did a study in Herefordshire for a project, and there's actually vast amounts sitting there in the woods to come out. So I think that over the sort of lifetime of a boiler, if you're talking 20 years, and this is only my view, and it's difficult to get hard numbers to back this up, but my view is certainly there's a lot more wood there than this suggests. That demand at the moment, existing demand, is not that high, but the big unknown is what the demand is going to be with the HRI, and also what the co-generators are going to do. Now, you hear these things, see them in the paper, oh, Drax is going to burn 1 million tonnes of wood. Now, and people are putting in power stations, like in North Lincolnshire, which will burn wood. Now, what you have to remember is that most of that wood is going to be imported. So, and that's why some of these things have been built right on the port side. So people can stand there and say, hang on a minute, there's too much uncertainty, and I don't want to overemphasize that, but it's something which has to be addressed. But some people are standing there and starting to say, well, am I going to spend £1 million on a system and then find I'm going to be up against it in terms of price and availability of wood fuel? After oil and gas, wood is the largest traded commodity in the world, and every day there are huge bulkers travelling around the world for basically to feed the paper industry. There are vast amounts of wood in Canada, we know in Russia, Scandinavia, but elsewhere, Brazil, eucalyptus chip, for instance, and in Southeast Asia, rubber chip, which is basically just a waste. There are already plans to import these in large amounts into the UK. So, On the one hand, we've got increasing demand, which is going to tend to put price up, but on the other hand, there's a lot more wood there than this suggests, which is going to moderate that, and on the other hand, there's going to be a lot of imports to moderate that increase in price. So what I can't say is, just, I'm not a crystal ball gazer, is what's actually going to happen to that price. Okay, but in the same sense that I don't know what's going to happen with the oil price and fossil fuel prices. So it's a view that you have to take, but based on actually going and getting some advice and thinking it through, particularly what's going to happen locally when you've got local supply. You're not going to build a 6 megawatt plant if the guy next door is going to build it and you're going to be directly in competition for those supplies, perhaps. Maybe you are. But there are other things you can do about this. So which I'll come on to. Now, in terms of straw, there's a lot of straw around. Okay. When it comes back to forest wood fuel, there's at least 3 million tonnes out there available. Okay, that isn't tied up. Straw, that equates to about 3.5 million tonnes. It's quite a cheap fuel, and there's going to be a lot less competition because it's more specialist equipment, and for the smaller boilers, they all burn wood. Okay, but the one that's ignored quite a lot is this waste wood one here. If you look at that amount, it's actually about equivalent to all the forest fuel and all the straw put together. You say, oh well, I'll burn waste wood, and particularly when I show you some of the prices. But that is not a single grade. All waste wood is not the same. Within that, there is treated waste wood, which may have paint on with cadmium, lead, and other timber treatments with arsenic in, copper, and that has to go through a waste incineration directed plant, which burns it at 1100 degrees C, gets rid of any dioxins and the rest. That is a very expensive plant, and really a minimum size plant to do that, which starts to get quite large. But that may still be within some of the larger boiler spectrum considering here. But there's also
minimum size. What sort of figure would you put on that?
I wouldn't. Certainly, if you're talking 4 or 5, then a wood plant, megawatts, wood plant is starts to become attractive. You have to plug it in with your local supply of waste wood. I mean, that's basically, it's coming through the existing waste industry. A lot of it it just goes straight into landfill. Some of it goes into some of the larger wood burning plant. Okay, but yes, it does. Now, this is when things start to become complex, because the waste industry, they're pretty clued up. Okay, they've got it fairly well sewn up to a great degree. To actually break into the waste industry, I know because I've tried. Okay, is actually harder than you think, and the reason is the way that it's collected. Skips and the rest, you're effectively setting yourself up with a waste license to move it. Now, if you're doing large amounts, that may pay you, but then there's also you've got to think about the processing of it. So you need large specialist drum chippers to chip it up with big magnets to take out all the rubbish. Okay, it's more complex than you would think, and a lot of them have long-term contracts with public authorities, and to actually break into that industry is quite a significant. It's very entrepreneurial, and some of those boys are very sharp. Yeah. Well, the gate fee at the moment, it depends entirely on what that wood is. If it's wood, then you're talking about something like £15 to £30 a tonne, depending, is the gate fee. But that really depends, because where there's a market for it, people are undercutting each other continuously. So that gate fee is diminishing. So what I don't want to do is turn around and say, oh, you get a 30 quid gate fee on that, and you go along and you find you get absolutely nothing. Because these boys know that there's an opportunity. But within that waste wood, there's other cleaner wood as well. Things like waste pallets, which is a vast amount. I know, for instance, one company that has 3,000 tonnes of very clean wood. It comes in, it's the packaging for windscreens in a big warehouse. They got 3,000 tonnes. They spend about £100,000 a year getting rid of that wood, but it's clean. It is for in terms of regulatory purposes, it's the same as forest wood fuel. Okay, so you can burn it. But the problem is, for some people, smaller installations, is that you actually have to prove that it's clean, and there are no standards to do that. So at smaller installations, people are taking on a risk, because if they buy it in and then the local authority then turns around and says, yeah, you can't burn that, or you can burn it, but you've now got to go and spend an awful lot of money for emission monitoring and the rest, and license fees and all the hassle that goes with it. And people have shied away from it. So there's a big opportunity in that waste wood for larger, people like yourselves, to actually go out there and do it. It's not actually that hard, as long as you do it in a reasonably logical and informed way. So I'm going to come on to a few prices. Okay.
I was talking to somebody a couple of years ago. I was looking at some quite significant volumes of wood, chipped, processed, if you like, ready to burn, and that was basically the cost of transport. So the wood at source, ready chipped, was free, if you like, and then you paid transport on it.
Well, we'll come to that in a moment, because we've got some sort of prices, and they are only indicative. But if you want to find potential wood fuel suppliers, there's loads of information. You can look at those later on in terms of there's websites, national marketplace, the Forestry Commission. Well, maybe not after yesterday's announcement, but there's a Carbon Trust database, which is going to be published soon. Again, Forestry Commission, regional wood fuel offices, I think they're the first to go in the redundancies, so we can take that off. But the regional development agencies, they're mostly gone after April. But the Forestry Contractors Association, the Country Landowners Association are quite good as well. But and estates and the usual suspects. Sawmills might be quite good. You get slab wood, the round bits when you cut off, and that can be sometimes picked up for a reasonable price, although there's increasing competition for that. But forestry contractors, tree surgeons, cooperatives. For straw, well, pick up the phone up your local farmer. But the British Hay and Straw Merchants Association, they'll put you in touch with straw dealers. And they also have updated straw prices by region, which is quite useful and quite accurate. Factors affecting fuel costs, well, obviously logistics, quality and the market. We've already covered that. We won't spend too much time. You probably know this very well. I put this in here because sometimes mixed audience, delivery cost is not directly proportional to distance. Okay, what is much more important really is the cost, because the time taken for deliveries. And I've put an example in there. Basically what it's saying is pellet blower lorry, I'm talking about wood pellets now, quite a large capital bit of equipment, 150,000 quid, quite high operating costs. You've got to have 300 quid a day margin to cover that, and they usually do that, these guys, smaller, they want 2 loads a day. Okay, anything after 2 loads a day is their profit. It's not brain surgery, it's very rule of thumb. And you can add in your O&M costs. So basically what it's saying, a 30-mile round trip is 170 quid a load, but a 60-mile round trip is 260 quid a load. I'd make that point because we're talking about fuels here. Fuels by definition travel. And some people really limit themselves, particularly public sector and organisations which are driven on environmental criteria alone. They really restrict themselves, and they say, oh yeah, but the CO2 footprint. The CO2 footprint for running this over 60 miles is not that high. For wood chip, it is 95% plus neutral, carbon neutral, and 5% in harvesting, chipping, transport, okay, or less. So this is often overestimated, but basically what it is saying is that if you delay in terms of speed of delivery, you're going to pay sooner or later. So I see crazy occasionally people have said, oh yeah, well you can blow chip. Well, chip, you can shovel it fast and blow it. You're putting in masses of energy, and people say, oh yeah, but it's cheap. you can put an above ground store, and you just have a hole and pipe it up, and you blow it through something akin to a pellet lorry. But it just doesn't stack up, because you've got the lorry sitting there revving its engine off, using as much fuel as it would going down the motorway at 50 mile an hour. And I can shovel it faster most of the time. There are a few specialist lorries for some small installations, but I don't recommend it. But what I'm basically saying is, you want something to come in, discharge and get out as fast as possible, otherwise you pay. And in this case, it's a minimum of £2.50 a tonne of delivery for per hour delay for a 20-tonne load of pellets. And over the lifetime of the boiler, you've got to remember that the biggest input, the biggest factor with respect to the economics of this, of any biomass, is the cost of fuel. It dwarfs the capital cost over the lifetime. There's also seasonal variations in price. Obviously, we know this with straw. You can pick it up straight off the field in the summer. If you can store it, or if you've got a summer load, you can cash in on this. And some people really ignore this. They come along and they have this one fixed price, and they don't realise they can get out there and haggle a bit and get significant discounts. Okay. Often fuel suppliers, such people with chip, they have insufficient storage space, and they want cash flow. So you can go along and you can negotiate on that quite hard and make significant savings. Not perhaps the whole year, but you can certainly come in on a spot basis and make significant savings. Up to 20% discount, sometimes even more, depending. Okay. And now, if we just have an example of a few prices, just to give you some idea. 30% moisture content roundwood chip. Now, if it's a larger installation, 500, 250 kilowatts and above, really, I wouldn't recommend that you start specifying on 30% moisture content chip. It's more expensive for the reasons I've said, and you're restricting your flexibility for the future. 40% moisture content chip, you see the price comes down. 50% sort of whole tree chip. This is a contractor's coming in and they just chuck, the whole tree goes through motorway clearance, that type of roadside clearance, railway clearance, and they just want to shift it quick. The price comes down. Okay. 30% short rotation coppice chip. Now this does vary place to place, but certainly up in the main short rotation coppice, so that's up in North Nottinghamshire and Yorkshire and Lincolnshire. A lot of that is going into the power stations because they get additional rocks for that. Okay, so there's almost a separate market. But further you get away from those projects, then the price comes down. Good quality pellets, they're expensive. Okay, these are blown deliveries. I'm talking 10-ton blown deliveries there. And really, for larger projects, when pellets starts to become very expensive. It's an international traded commodity, and you can go out there, buy direct, and do all sorts of things. But you're competing with Austrians and Italians and the rest. Now there are a significant pellet supply coming online, but manufactured pellets is not cheap inherently. You've got to dry the wood down somehow from natural air drying, which you can get down to about 25% with seasoning, depending where you are. You've got to get that down to about just above 10% to put it through. Then you've got to grind it up, and then you've got to put it through your pellet press, your pellet mill. Seasoned softwood logs. Okay, you'll see that the price there is actually much higher. If you're in wood fuel, logs are good margin. You can buy cheap chipwood for 20 odd quid, depending where you are, 20 odd quid, 25 quid, perhaps a ton. Chop it up, put it through a log processor, and you can make, in some parts of the country, good money. And the number of stoves has increased. The sales of stoves last year was sixfold what it was 3 years before. Okay, when you get to your posh logs, I must have ash. You're talking about significant prices here. Okay. 20% moisture content, which is sort of typical for pallet wood, thereabouts, sometimes drier, sometimes a bit wetter, but this is non-waste, non-wood waste wood. You can still pick that up, and it depends. You can go and hunt around for that. I know some very good suppliers. They've got surplus of this. You can get that down, you know, nearer to that 25, because they are getting a gate fee in some cases. Now there's going to be more competition for that, as I said, as time goes on. But there's a significant opportunity as long as you tie yourself in, and I'll come to that. And then wood, I put £20 really. That can be cheaper, but what I'm basically saying is that is really reflects the cost of they're keeping the gate fee. They're really charging you for putting it through a large tub grinder and across the magnets therein, sorting it out and delivering it to you, and then the price comes right down. So we're not talking about a uniform price across here by any means. Wheat straw, I put £50 to £60. You can have a look at the website. It was trade-in straw in Lincolnshire. It was at the farm was £38 a tonne last week plus transport. So probably at the lower end of that if you put in 12 quid for transport. It's quite a cheap fuel. And then I've put in some for heating oil. Obviously, I meant to change that actually. That should have gone down to 55 because the 72 was the 1st of January when we had that spike. It's dropped back down now. I haven't looked this week, but last week it was 55. It may have dropped a bit further. Expensive and variable. And LPG, and you know what you pay for gas. 2.5 pence kilowatt hour, and that'll be talked about that later. You can find spot buy bargains. Okay, but don't base your economics, your long-term economics on that. Future price trends. Well, we know supplier and transport costs are increasing. I don't know what it was last year, but I suspect it was a lot more than 8%. Fuel demand increasing, projected to increase steeply because of the feed-in tariffs and the RHIs. And competing uses, such as the board manufacturers, etc., will increase as the recession ends. So the short-term price trend is up, but as I said, in terms of pellets, there's significant overseas pellet production. Now that probably doesn't interest you because it's an expensive fuel in terms of the volumes you would need. We're talking more about chip and straw. But there is vast quantities of good quality chip available overseas, which is traded at low price around the world. Okay, the whole of Japan's paper industry is based on imported chip. So there are plans to put in facilities which are at an advanced stage, to put in facilities as soon as the demand goes up, to start bringing in material like that in big bulkers into some of the East Coast ports. So they will limit UK price increases over the medium term, but as I said, I'm not a crystal ball gazer. I can't predict what it's going to be. If you want to have a look at some example wood fuel contracts for people buying in, there are examples on the Carbon Trust website. I'm going to be updating those over the next few weeks, but they'll give you an idea of sort of terms that go in. They're not that sophisticated. What I get involved in now is much more complex because people are sitting there saying, well, hang on a minute, I want to start buying forward. Now, obviously for the fuel supplier, there's diesel costs, fossil fuel costs. There's also inflationary issues, but the major cost for them is the raw material. So as a wood fuel supplier, it's got to go out there and buy at variable price. They're not going to fix. So you need some sort of indexing. The problem with this is that unless they can fix back into that supply chain, and not many people are willing to do that at current, well, no one's willing to do it at current market price. So basically, there's not much difference actually than buying a current market price. Really, all you're doing is actually minimising their margin. But some chip producers are willing to enter into long-term contracts, and I'm working on one at the moment, which is basically, it's a base price, it's current chip price plus that actually has gone up that 10%. But it allows the producers to lock in wood producers using back-to-back contracts. So what they're doing is going out to people who own wood and saying, look, I'm going to pay you above market price, X above market price. And you think, well, why would they want to do that if they think it's a rising market? But what it actually enables some of those people to do is that it's fairly complex industry, and the forestry and land management, we could spend all day talking about it, but it allows some people, particularly intermediaries like forestry management agents, to say, I've got a guaranteed income on that. And what's happened in the past is it's very difficult for them. Somebody's got to stump up money to go and bring that wood out, which can cost, has a cost to it, to bring it to the roadside. And then they're on a variable price, and sometimes, if any, particularly if it's small loads. If you can actually get guaranteed price at the roadside, it means that they can plan ahead, and it's bankable, and they can go and raise finance on the back of it. So suddenly it makes their life much easier. So if you can plug into that, it is possible, okay? And more people are starting to think this way, because they say, I'm prepared to pay a margin now to get 3, 4, 5 years stability, and the value to me is that I can actually plan my cash flow and talk to the bank and the rest of it, without this spectre of variable fuel price raising its head.
Glyn, have you ever looked at payment per megawatt hour of heat produced? Or?
Yes, I mean, we could have gone into all of that. I mean, more and more, why go and buy by the ton, and then you're locked into, you have to start to consider moisture contents, and then how you're analysing it, and sampling regimes, and there's always variability in there, as we know. If you do it, as long as you agree a boiler efficiency, okay, and as long as the boiler operator is having if it's got automated flue cleaning and the boilers serviced pretty regularly, okay, particularly on base load, it's pretty predictable. Okay, so you've got fuel input, loss in energy through conversion, and then an output. Well, the output you can measure very easily through heat meters, plus or minus 2%. So more and more people are just having contracts where they say you supply the fuel in between these parameters, and it may say between 30 and 40% moisture content. There's some complexities in there, but basically say that, and then we'll pay you per kilowatt hour out of the boiler. More and more people are doing that as time goes on.
Indexation to say gas or oil price or anything like that?
Well, people have messed around with that, but then a lot of people who want to go down the biomass route don't want to lock themselves into those rising prices. You can start to get very complex, and you say we'll take 30% of the price on oil prices and all the rest of it, because you know that you can work out on any operation. I did it recently, and in terms of costs, the fossil fuel input costs into producing chip and that was not red diesel, by the way, was about 13% in terms of total cost of production of the chip. Well, you can easily work out, what the cost inputs are. So there will always be an inflator in there for fossil fuel in terms of buying that chip. Okay, because the fuel supply doesn't want to get squashed. But if you try and increase that, then it's the fuel purchase. So do I really want to be locked in what I'm pretty damn sure, let's say for oil prices, is going to go through the roof? And then for gas prices, there's been historically there's been quite a lot of fluctuation there in terms of wholesale gas prices. So which index? And it's your view. It's your view. You're the people that may be buying. And so it's what's your view of the future, and I can't instruct you on that. All you can do is lay out the basics of where price trends are likely to go, and then you have to look at your situation in terms of cash flow and risk and risk mediation in terms of your own businesses, and say what suits me. Now you're all business people, you all know about contracts and all the rest of it, so you're probably as well qualified as anybody to sit there and do that. But it's how does it affect your business? And you have to look at your own financial situation and cash flow, etc., to determine that. So, it'd be lovely to turn around and say, oh, it's wonderful and it can do all of these things. Technically, it can. You can do all sorts. You can produce steam. You can do all of these things. When it comes down to it, what's the return and what's the risk? Okay. Well, cost, return, and risk. Okay, and this is the variable that nobody can say. My own view is, and what I did when I started, saying, if it was my money, what would I do? Okay. Certainly I'd wait till the RHI document and read the small print very carefully. But I would, if I were at the sort of scale that some of you are talking about, I would be looking very closely at straw. Very closely at straw, and I would be looking very closely at clean waste wood. And if you're big enough, I'll be looking at wood, okay, and looking at those options very closely, because there are opportunities here to knock the bill with minimum risk. But what I don't want to do is oversell it, because there's been too much overselling in the past of these things. So you must be aware of the risks and treat them accordingly. Is that fair comment? So any questions really? Sorry? Wood. It's wood fuel which has got to be burnt through a waste incinerator directive compliant piece of equipment. Okay, so a typical wood fuel boiler, it may be burning wood, and it may be operating up to 700 degrees. Sometimes below, but let's just say, for example, a wood incinerator has got to go up to 1100 degrees, and it burns any dioxins and the rest of it. And you also have to have monitoring. When I worked for Shell, we bought a business in Sweden, and it was burning supposedly clean waste wood, but of course the wood fuel contractor was very incentivized to chuck a load of rubbish in the bottom because he was getting a gate fee. And the Swedish authorities came along and sampled. We got shut down because of copper, arsenic, you name it, coming out the spout. And it was very embarrassing and very, very costly for a large plant. And we should have been a bit more savvy to monitor the situation ourselves. But basically, what they will say is if you're putting in stuff like that, so what's coming out the spout, so you will have particulate abatement. Now, Matt talked about the fly ash. The fly ash, because a lot of these heavy metals actually vaporize at higher temperature, and then they condense. The fly ash can actually be quite toxic. You actually enrich things like cadmium and lead and whatever. And so you have to have very good particulate removal as well. But then you also, they need to be pretty sophisticated bits of equipment, because you're running at very high, quite high combustion temperatures, so you need specialist steels, but you also have to have very careful monitoring of combustion conditions, not to produce too much NOx. NOx can be produced from the oxidation of atmospheric nitrogen. So you can put no nitrogen in, but still get, in terms of your fuel, and still get a lot of nitrogen coming out your spout if you're not careful. So they're quite sophisticated bits of equipment. They're quite expensive bits of equipment, and but there's an awful lot of material there to be burnt. Now, at a small size, the economics of it, just the capital costs become very, very prohibitive. But once you get to certain sizes, okay, size thresholds, it can start to become a lot more attractive. But we have to wait and see what it says in the RHI document. Are they, saying, oh, it's all got to be clean wood, virgin wood, or count as virgin wood? So, we've got to bear that in mind. We were hoping that now, the documents were promised in December, we were hoping that we'd be able to talk to you from a knowledgeable position. We think we know what might be in it, but we don't want to second guess it and lead anybody astray.
The other thing on wood is the perception from a planning point of view.
Oh God, yeah.
That's the other big stumbling block.
Yeah.
It's an incinerator. Gets people excited rather easily.
Yeah.
I've got in mind that a ton of wood chip is roughly equivalent to 150 litres of oil. I don't know if that's right or not.
No, that's wrong.
Wrong.
A litre of oil has got a net calorific value of about 10.3, 10.4 kilowatt hours. Okay, that's net if you're putting it through a non-condensing boiler.
So
to about 10.3 kilowatt hours.
Right. And
so a ton of wood at 30% moisture is about 3.5 megawatt hours of energy. At 40% moisture, it's about 2.8 megawatt hours of electricity, of energy. So divide one by the other, if you call it 10, okay, even at 40% moisture content wood, you've got 280 litres or thereabouts of oil.
So what's a ton of straw worth?
A ton of straw is about 4.1 megawatt hours per tonne. Okay, so that's actually equivalent. It's pretty much equivalent to wood, but it's a lot drier than 30%. Typically, you're around the, somewhere between 15 and 20%. Typically, it's around 17% for straw, and you get about 4.1. Depends on the type of straw. That's wheat straw. It's different from rape straw, but not that different. Yeah. Okay. I'll have to go and look it up because my memory's bad. Pardon?
How does that work back?
Well, how that works back.
I can just interject. John's got a simple sort of spreadsheet calculator thing that John's going to run through this afternoon.
Yeah.
We'll make copies available to you. You'll be able to put in, right, I've got so much oil at 50 pence. How many tons of straw do I need to do that? At what cost? Actually, he does those conversions for you. So that's something that John will talk about.
But if you're working like, it's about 380 litres for a ton of straw. Yeah. I haven't got my calculator, but it's not far off that number.
Oh, yeah, as you'll see this afternoon, the comparison of biomass fuels, even without a renewable heat incentive, compared to gas oil, for example, its biomass fuels look reasonably interesting without any incentives. If you're burning oil at the moment, if you're burning gas, the differential isn't quite the same, and that's where the renewable heat incentive comes into play. But we'll see some of those numbers, or hear some of those numbers this afternoon.
See, I think where you score is if you can get that base load. So a lot of people don't want to come along and use biomass in circumstances which aren't optimal. They want to heat very modern office buildings which have high insulation with very spiky and peaky heat demands. Or you want to heat a school which operates 30 odd weeks a year, between the hours of 9 and 5, 5 days a week, and the heat demands aren't there. But if you can get a base load system in, then it really starts to score. And as you'll see, as John will go through later.
And that's typically why the sector
yeah. Yeah. Your industry comes up, if you do all the metrics and you run through the fundamental economics, your industry comes right up there, okay, as one of the ones that can benefit most from biomass.